Now in today's session we will be discussing about this algebraic identities. So when we say identities means it's a fixed result, a kind of formula. It's true for all the values of a and b, whatever it is given. Whatever the variable it has, it is true for all the variables, all the numbers. Okay. So the basic identity is square of a binomial. The square of a binomial it is, we see generally a plus b, it contains two terms. The square of a binomial it is a square plus 2ab plus b square. How we got this? Previously we have seen multiplication of polynomials. Okay, so now binomial into binomial, in that method we can work out this and we will get this answer. So this a plus b whole square can be written as a plus b into a plus b, and you do the multiplication of two binomials, you will get this answer. Same like now a minus b whole square, wherever b comes in place of b, we replace minus, but that minus will only affect in this odd power, not the even power. If we replace minus in here, we will be having a square minus 2ab, because 2a into minus b will get that plus into minus is minus, plus minus b whole square it is positive, plus b square. That is it. So this is square of binomials, and square of trinomials also is there. What is square of trinomials? A plus b plus c, three terms. Okay, the three terms, when you square it, how to work out this? We consider same, but we will use this identity, or else we will take this as a plus b plus c into a plus b plus c. In the other way, we can take using this identity by considering these two as one. Okay, so now this identity is a square plus b square plus c square minus 2ab minus 2bc, plus 2ab plus 2bc plus 2c, and in general this can be sometimes summarized like this 2 can be taken out as common, so ab plus bc plus c, just like we can write. This also, there are several cases in which either one variable gets negative sign or two variable gets negative signs, or else some three variables also will may get negative sign. So suppose if b alone negative, we have a minus b plus c whole square, that is equal to, the same identity will follow, but wherever b comes in the odd power, there negative sign will come. See, a square, b square is there, so even power, negative will not affect here. Then c square, 2ab, b has odd power, so minus 2ab minus 2bc plus 2c, and the same will be equal to minus a plus b minus c whole square as well. Both are same. Why both are same? What you find difference from this to that? You take negative out from this trinomial, what you will get? Minus of minus a plus b minus c. So this minus gets square, it's positive, then this square is that one. Okay, all the possible cases we are about to discuss. Now a plus b minus c whole square, c gets negative, then what is our identity? A square plus b square, c has even power, so it is positive. Then can you say what is our identity? Plus 2ab minus 2bc minus 2ca. Wherever c comes in the odd power, we will have negative, and that is equal to the another one. What is that? Whole square. Okay. Next, the other possibility is a gets negative. So a plus b plus c. We have a square plus b square plus c square minus 2ab minus 2ac plus 2bc, and that is equal to the other one, a minus b minus c whole square. Okay. Now in the same manner, if we equate, means this also can be equated to other one. What is that? Minus a minus b minus c whole square. So in this way we equated all the possible identities of the square of trinomial. So whenever it occurs, we can find. Also, you should not only depend upon the left hand side. Whenever left hand side is there, we can apply the right hand side. Whenever you find a pattern of this right hand side, you should know how to apply this left hand side. Both ways you should understand. That's how the formula, the identity works. Okay. Shall I erase everything? Okay. This is square of trinomial. And then a special product also there. Okay, the cube of binomial is, let's see. Cube of a binomial, that is simply a plus b whole cube. So the a plus b whole cube, how this can be done? It is simply a plus b whole square into a plus b. When you multiply in this form, you will get a cube plus 3a square b plus 3ab square plus b cube when you multiply this. So this is the identity of cube of a binomial. And then guess what? This identity has to be equated. What are all the ways it is possible? See, the same identity we can say like a cube plus b cube plus 3ab into a plus b. What I have done? I just transposed the things and taken common things out. That is it. So a cube plus b cube plus from these two 3ab can be taken out. If 3ab taken out means here a alone be there, b alone will be there. So 3ab into a plus b, that is it. Now from this we can equate the value of a cube plus b cube as well. So each step is a formula. So that formula is a plus b whole cube minus 3ab into a plus b. Okay. The other way around, we can take a plus b out. If you take a plus b as a common, then you may have a plus b whole square minus 3ab. Then what you will have? A plus b into a square plus 2ab plus b square minus 3ab. Then we will have a plus b into a square minus ab plus b square. So this is another identity of a cube plus b cube. Whenever it is required, we can apply this, either this or that. Okay, which one I said? This one or this one will apply. Now the same way, a minus b whole cube. Guess what? What would be the value of a minus b whole cube? Simply what we done previously. Wherever b occurs in the odd power, that gets negative. We are simply replacing b by minus b. So we are getting a cube minus 3a square b plus 3ab square minus b cube. Now what are all the ways this can be equated? A cube minus b cube. Here minus 3ab we can take out. Then we may have a minus b. Correct? Minus 3ab into a minus b. Then when you multiply this, minus 3a square b plus, okay, that is it. So this is another formula. That is general form. This is another form. Now from this we can equate something. What was that? A cube minus b cube. That is a minus b whole cube plus 3ab into a minus b. The same way if you work out this as well, the same way what we done here can be applied here. Then what we will get is a minus b whole cube, a minus b into, that can be taken out. We may have a square plus ab plus b square. Okay, because here plus 3ab, here plus 3ab will be there, here minus 2ab will come, so plus ab will get. So this is also an important identity, these two. Have you written everything? Okay. Next. One special product, special identity is there. Why it is so special? You just see. It is a cube plus b cube plus c cube minus 3abc equals a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. That is it. Simply when you multiply this inside, you will get this as your answer. A cube plus b cube plus c cube minus 3abc. This is one kind of special identity. Now using this, we are going to solve some questions from your exercise. Also another identity for that. X plus a into x plus b. What is this identity? Simply product of this. We are not comfortable of doing this every time. Whenever it occurs in the question, we are not comfortable. Simply we apply identity, that's all. It saves time. That is why. So in this form, if you see, means you can write like x square plus a plus b into x plus ab. Now this also has several variants. A gets negative, b remains same as positive. So wherever a comes, we replace minus. That is it. So x square b minus a, or else minus a plus b into x minus a. The same way, if b gets negative, x square plus a minus bx minus ab. Both looks like same, right? Isn't it? Is the both identities are same? No, both are not same, because b minus a is different, a minus b is different. Now, if both gets negative, then what we will get? Minus a minus b. Then that minus can be taken out. Minus of a plus b into x. So minus a into minus b, it is plus a. That is it. Okay. Now why we are learning all this? Who asked this first of all? Suppose there is a question 103 into 103. You know how to multiply. You can multiply simply. But this identity will help you. How this identity will help you? This can be written as 100 plus 3, 100 plus 3. So that can be written as 100 plus 3 whole square. Which identity this one? A plus B whole square. Suppose you have 99 into 104. Then what identity will be applied? 100 minus 1 into 100 plus 4. Which identity among this? X minus A into, simply we can write, is it? We will write answer in one step. X square, 100 square is 10,000. 10,000 are you here? 1 followed by 4 zeros. Then here B minus A. What is B? 4 minus 1. This 3 into 100, 300. Then here minus AB. So minus 4. That's all. Right, 3 steps and we add everything. That's how it works. This type of questions may be asked. Now we'll get back to the exercise. Did I left anything? Any identities? No. Okay. Expand or simplify the following. Question number 1. X plus 2y plus 6z whole square. What identity can be applied here? A plus B plus C whole square. What is it? What is A? What is B? What is C? This whole thing can be considered as A, and this whole thing can be considered as B. This whole thing can be considered as C. So here we wrote ABC directly, but when our product of 2 comes, we should put a bracket. Okay. So here A square means simply X square plus B square. The second thing has 2 things in a product, so we'll put bracket 2y whole square. Then this has 2 things in a product. Then 6z whole square plus 2 times AB. A is X, B is again 2 things, so I am using bracket 2y plus BC. B is 2y, 2 things as a product, and C is 6z plus CA. This 6z into A. 6z is in bracket. That is why we are using brackets. Now when you multiply this, x square plus, expanding this 2y square can be expressed as what? 2 square y square. Laws of exponents. When 2 numbers have same power, you can distribute the power to both numbers. Are you getting it or not? Okay. So 2 square is 4, y square is y. So 4y square plus 6 square is 36, z square is z square. That is it. Then plus 2 times, here we have 2xy plus 2 6 are 12. See, we have seen product of 2 monomials. That is what happening. So 12yz plus 6xz. This 2 also can be multiplied and we can write the expanded form. The same way, the other question is also there. Minus 3x plus 2y minus 3z whole square. Then how this can be done? Using the same identity, but here negative, here negative. If you are not comfortable with the 2 negative signs, take one negative out. 3x minus 2y plus 3z whole square. This we can simply expand using this identity, but consider this b as negative. But if you don't know how to do this, don't do this. Better go with this. Clear is? So this will you do this on your own? Is it very tough? Okay, good. Now the next one. Okay. Look at this one. How this can be done? We expand both the terms, we'll cancel each other. That's all. So when we expand this, what we'll get? In terms of ABC, we assume here PQR is the same identity. P square plus Q square plus R square plus 2PQ plus 2QR plus 2RP. See, what is the thing you notice here? The 2 over the bracket I didn't use here because other thing is also there. You should cancel this. That is it. Now here P minus Q minus R, same thing. P square plus Q square plus R square. Wherever Q and R comes, you should put two negatives. So here Q alone, where it is coming? Here Q alone is there. So this term is negative. 2PQ minus 2PQ. Now here both Q and R is there. For Q1 negative, R1 negative. Negative into negative, that will become positive. So plus 2QR. Now here R alone negative, P is positive. So we have negative R. Anything gets cancelled? The addition and subtraction of algebraic expressions, like terms. What are all the like terms here? Plus 2PQ minus 2PQ. When we add this, that will become 0. That is why we are crossing that out. Then here 2RP. Then the like terms P square plus 2P square, that is 2P square. For your understanding, I wrote in this form, one below another. But while you are writing, we can write whatever the form. But if we write in this form also, it will help you. Now this is 2Q square. This is 2R square. Then here plus 4QR. That is it. Any doubts on this? Okay, good. The next one. Expand A plus 2B whole cube.